കുട്ടികളെ നമ്മൾ ഇന്ന് ചെയ്യാൻ പോണത് സബ്സ്റ്റിറ്റ്യൂഷൻ ഇൻ ട്രിപ്പിൾ ഇൻറ്റഗ്രൽസ് എന്നുള്ള ടോപ്പിക്കാണ്. സബ്സ്റ്റിറ്റ്യൂഷൻ ഇൻ മൾട്ടിപ്പിൾ ഇൻറ്റഗ്രൽസ് എന്നുള്ള ടോപ്പിക്കാണ്. മൾട്ടിപ്പിൾ ഇൻറ്റഗ്രൽസിൽ ഡബിൾ ഇൻറ്റഗ്രലും ട്രിപ്പിൾ ഇൻറ്റഗ്രലും എല്ലാം പെടും. അപ്പോൾ നമുക്ക് സിംഗിൾ വേരിയബിളിൻ്റെ ഒരു എക്സാമ്പിൾ നോക്കാം. നിങ്ങൾക്കൊക്കെ അറിയാവുന്നതാണ്. If you want to evaluate integral 0 to 1 x plus 1 whole square dx, one way is to expand x plus 1 whole square, so x square plus 2x plus 1, and you can then integrate. Another way is to put y is equal to x plus 1, therefore dy will be equal to dx, and when x is equal to 0 y will be equal to 1, and when x is equal to 1 y will be equal to 2. So this becomes integral 1 to 2 y square dx is dy, and when you integrate you will get 7 by 3. Okay, so this method is called substitution. So this is in the case of a single variable. So in two variables, what is the rule for substitution? That is what we are going to investigate. So substitution in double integrals. Substitution in double integrals. So suppose we have to integrate a function f of x comma y in the xy plane. So this is the xy plane, this is x-axis, this is y-axis, and we have a region R in the xy plane. This is the domain of the function f. F is a real valued function. This is the real line, and we have to compute double integral over R f of x comma y dx dy. Sometimes this will be difficult to evaluate in R, in this region R. So what I do is I will define another region in the UV plane. So another plane I will consider here. So this is, let us say, u axis, v axis, this is the UV plane, this is the origin, and suppose this region R is transferred to, let us say, the region G in the UV plane under a suitable transformation. So from here to, from R to G you can go, from G to R also you can go. That means you have a 1 and 1 function from R to G. So suppose the transformation is x is equal to, so Here any point x comma y I can represent, and here any point u comma v I can represent. For each x comma y here I have a u comma v here, and for each u comma v here I have an x comma y here in R. So that transformation will be denoted by x is equal to g of u comma v and y is equal to h of u comma v. Okay, now from here to here also I can go. For each x comma y here I have a u comma v here, like that. Now look at the composition. So this was f of x comma y. But x is equal to g of u comma v and y is equal to h of u comma v. So I am going to integrate over this region g. To find this integral, I will integrate over the region g. So how it will be transformed? So this is equal to double integral over g f of what is x? X is g of u comma v, g of u comma v. This is x. Now what is y? It is h of u comma v into, now what is dx dy? Dx dy is not just du dv, it is something else. So it is j of u comma v. It will be called Jacobian. Its absolute value modulus into du dv. I will tell you what this is. This Jacobian, j of u comma v, what it is. But the point here you have to note is that dx dy is modulus of j of u comma v times du dv. Dx dy is not just du dv, it is du dv multiplied by this modulus of j of u comma v, and it is called Jacobian. And double integral over R, this f of x comma y dx dy equal to double integral over g, this quantity, this equality by this double integral over R equal to this double integral over g. That is, the proof of that result is beyond the scope of your course. It comes in advanced calculus, so we will accept this. We will accept this. This means the proof of this result. Now what is Jacobian? Jacobian, it is a determinant where j of u comma v is equal to determinant dou x by dou u, dou x by dou v. Here you can find x as a function of u and v and y as a function of u and v, and this Jacobian is this determinant dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So it is assumed that this g and h, they are partial derivatives. with respect to u and v. That means x and y whose partial derivative is with respect to u and v, they exist and continuous. Such kind of transformations only we accept. And f of x comma y, the integral over that is equal to the integral of the composition. So this function is precisely the composition. This function is precisely f of u comma v, but u is g of u comma v. So start from here, reach here. So it is a g of u comma v comma h of u comma v. So this is the result in substitution in double integrals. We will discuss problems in the next video. Thank you.